Our identities are back, and we're going to use some of our double angle formulas to prove a couple identities. To begin this first problem, I'm actually going to start with this side of my equation and end up over here. Now remember, your double angle formula, to kind of help you get a guideline for where you're going to go, your double angle formula for sine was 2 times sine theta times cosine theta. So really, I want to try to get to there, 1 plus that really. So let's go ahead and start with this side and see what happens. So when I have sine theta plus cosine theta squared, remember what that really means is I'm going to multiply this by itself. So if I go ahead and add another sine theta plus cosine theta, I'll go ahead and multiply that out using FOIL, whatever you need to do to multiply that out. And so what I get is, first I'd have sine times sine, or sine squared. Plus, if I multiply the outsides, I'd have a sine times a cosine. And if I multiply the insides, I'd have another sine times a cosine. So really what I have is I have 2 of those. So I have 2 sine cosine, which again, remember your double angle formula, that's part of it. Okay, so we're getting there. Plus, then if I multiply the last parts together, cosine times cosine is cosine squared. Okay, and so as I mentioned, this piece right here, this 2 sine cosine, we already know based on our formulas that that's the same thing as sine of 2 theta. So I have that part done. What I still need to do though is figure out where they got the 1 from. Well, if you take a look at the beginning and the end of this, I've got sine squared plus cosine squared, and hopefully you recall that sine squared plus cosine squared is just equal to 1. So those beginning and end pieces become the 1. That middle piece I can condense down to just sine of 2 theta. And there we go. We've established that identity. I wanted to end up there, and I got where I needed to go. And we'll go ahead and take a look at one more. And again, I'm going to try to end up with this, the sine of 2 theta. And recall that sine of 2 theta is really just the same thing as 2 sine times cosine. So if I can get there, I can get where I need to be. So as we've done with similar looking identities in the past, let's rewrite this. Instead of cotangent, let's write that as cosine over sine. Okay, and then times sine squared. I'll leave that one alone. And then looking for anything that I can cancel out, well, I can get rid of that sine, and I can get rid of one of those signs. And so what I'm left with then on the top of this fraction, I guess, is I have 2 times cosine theta times sine theta. But remember, when you multiply, it doesn't really matter what order you multiply in, so those pieces could just be switched. So that's what I needed. I needed 2 times sine times cosine. So from there, I can just finish this by saying that's the same thing based on our formulas of sine of 2 theta. And so I've established that identity as well.